So the first thing we want to do when we solve a polynomial inequality is to factor if the equation that's given is in standard form. And we want to set it equal to 0 and find out where the x-intercepts are. So you pretty much ignore the inequality to start. You just concentrate on making sure that your equation's in factored form, that you can set it equal to 0, and that you can find the roots. So we're going to start by factoring. The first thing I'm noticing is that I can pull an x out of each of these terms. So I'm left with x times x cubed minus 3x minus 2 is greater than 0. And then looking at x cubed minus 3x minus 2, I'm noticing that it's higher than degree 2. So I'm going to have to try and break that down, hopefully with long division. So negative 2, I could try negative 2, negative 1, positive 2, or positive 1 as the potential factors to figure out with the factor theorem what my first or my next factor is going to be. So let's try, if this is p, the thing inside the bracket, let's try p at 1. 1 cubed minus 3 times 1 minus 2. That gives us 1 minus 3, which is negative 2 minus 2, and that's not 0. So x minus 1 is not a factor. So we're going to go back to the drawing board and let's try negative 1 instead. Okay, so now we have negative 1 cubed is negative 1. Negative 3 times negative 1 is plus 3, which is positive 2. Minus 2 is 0. So we have found that x plus 1 is a factor. So we already have 2 of our factors. So we're going to divide x plus 1 into x cubed plus 0x squared. It's important to put that placeholder in there. Minus 3x minus 2. So we're going to see how many times x can go into x cubed. Of course, that's x squared times. And multiplying x squared by x plus 1, we get x cubed plus x squared. Subtracting, I get 0x cubed and minus x squared. And I bring down the next term, which is negative 3x. How many times does x go into negative x squared? It goes in negative x times. Multiplying negative x by x plus 1, we get negative x squared minus 1x. And when I subtract, I end up with negative 2x. And I bring down the minus 2. How many times does x go into negative 2x? It goes in negative 2 times. Negative 2 multiplied by x plus 1 is negative 2x minus 2. And again, if you've done this correctly, your remainder should be 0 when you subtract. So now we've successfully broken down this polynomial as x times x plus 1 times x squared minus x minus 2 is greater than 0. One more factoring step here. We want to look inside at that quotient we just found. I can break that down with simple factoring as x minus 2 times x plus 1, and that's all greater than 0. So what I see here is a double root at x plus 1. At x equals negative 1. So that's what we're seeing here on the graph. If I put my x-intercepts on the graph, you'll notice that this point here at x equals negative 1, it's an x-intercept, but it's also a turning point. And we also have another x-intercept here at 0, which makes sense because you have x as one of your factors. And the last one should be at x equals 2. So my other x-intercept here is at 2, and I should be able to put those onto my graph. I want to know, where is this polynomial greater than 0? So in order to find that, what I need to do is I need to look at where is it positive. So it's positive here all the way to 0, and it's positive over here when x is greater than 2. So let's see how we're going to do that algebraically. Okay, so we're going to set up a little bit of a table here. We're going to start with, oh, I made a little typo here. This is x equals -1, sorry. We're going to make a table where we organize the values or the intervals according to the x-intercepts, where those are kind of like my fence posts. So I want x less than the smallest x-intercept. So this x equals -1 is the smallest. I want to know about what's happening with the graph when x is less than -1. And the reason that the x-intercepts become like my fence posts or my boundaries between where is it positive and where it's negative is because at the x-intercepts is where the graph potentially crosses the x-axis. So x is less than -1 is the first region I'm going to look at. You might also see this written as -1, or sorry, -infinity, -1, but you aren't expected to write it that way, but you might see it in the textbook as that. Between -1 and the next x-intercept at 0, that's the next region of the graph. And again, you could see this as -1, 0, means the same thing. The next interval is between 0 and 2. And I have to make this a little bit smaller here. And finally, the last section of the graph is for values greater than 2. So you can see that these x-intercepts became the values that I used here as my fence posts between positive and negative regions. Okay, so the next thing I'm going to do is I'm going to list all of the factors from the factored form on the left-hand side. So I'm going to create one more column over here. And I'm going to put all my factors in this column. So x was my first factor, x plus 1 squared is my second factor, and x minus 2. You only really need to include factors over here that are going to change the sign. So in fact, it's kind of interesting. I could leave this factor out completely because no matter what's happening with x, no matter where you are in the graph, x plus 1 all squared is always positive. If x is less than -1, x itself would be negative. If x is between -1 and 0, it's still negative. If x is between 0 and 2, it's positive. And if x is greater than 2, the factor x is positive. And just looking at what's happening in the last row there, if x is less than -1, think of a sample value like -2. If x is -2, -2 minus 2 is negative. If x is between -1 and 0, so something like -0.5, -0.5 minus 2 is still negative. If x is between 0 and 2, so something like +1, 1 minus 2 is still negative. And it's not till you get into values greater than 2 that x minus 2 becomes positive. Think of an example like x equals 3. 3 minus 2 is positive. And the last row here is sort of putting all of these factors together, the signs of all the factors. If we multiply them together, what do we get? So I'm just going to call this P of x, which is all of these factors multiplied together. And I end up with a positive result. If I have a negative factor and a negative factor, that makes a positive factor. And of course, x plus 1 squared is always positive. Again, it's positive between -1 and 0 because two negatives multiply to a positive. Between 0 and 2, we have only one negative factor, so overall it's negative. And when x is greater than 2, it's positive. So now if I look back at my graph of what I guess I'm now calling P of x, what you want to notice here is that we wanted the red highlighting on the graph. So that's what we had as the results in the columns as well. It was only negative between x is between 0 and 2, so only for this portion here. So that matches up with what we see on the graph. So what we're going to do is we're going to just summarize then. We want to know where it's positive. So x, P of x, we'll say is positive when x is less than -1, between -1 and 0. And we're not going to actually say when it equals -1 because that's where the x-intercept was. And we didn't want to include when it equals 0, when P of x equals 0. And when x is greater than 2.